Hi, I'm Miles Traer. In Earth's 4.5 billion year history, there have been 5 events called mass extinctions that reset the planet's ecology. But what caused these events? And how did it change the evolution of life on Earth?
To help answer these questions, I'm visiting paleontologist Jon Payne, an expert on mass extinctions and the long-term evolution of life on Earth.
When we see big extinction events, it's because something is happening in the physical world that is driving many species extinct. What people mean today when they say that we're on the brink of a sixth mass extinction is that at the rate that species are going extinct today, if that rate continues for any appreciable amount of time, say another couple of centuries or another 1,000 years, that by that point we would have lost as many species or as high a proportion of species as were lost in previous mass extinctions, which would mean something like 3/4 of the species on the planet. So,
That's
a
a lot.
really enormous disruption to the planet.
Payne walks me through the previous 5 mass extinctions and the changes in the physical world that helped cause them. Massive volcanic eruptions, severe ice ages, dangerous changes in ocean chemistry, and meteor impacts have all played major roles. But the real culprits were the environmental effects, things like climate change, ocean acidification, and drops in the amount of oxygen in the ocean. Payne has spent his career looking at how life responds to these environmental changes and how mass extinctions affect the long-term evolution of life on Earth. The animals that have gone extinct seem to share certain characteristics, like sensitivity to changing climates or acidifying oceans. Payne and his students are expanding on this research by looking to the past to help inform what species might be at risk today.
For the last 50 years or 60 years, people have spent a lot of time trying to study extinction intensity. And that's how we've defined these mass extinctions initially, is based on how much extinction happened. We've tried to figure out how fast the extinctions have happened. What we're doing now, where a lot of the attention in mass extinctions is going now, is toward 2 things. One is environmental reconstruction, so trying to understand how much did climate change, how much did ocean chemistry change, how much did atmospheric chemistry change. The other thing I've been interested in is looking at other aspects of animal function. So what ecological roles do animals inhabit, and how big are they? Because actually your size determines a lot about what your ecology is.
By identifying these common features, Payne can use the past as a helpful lens to help us look at species today.
What we can do is look to the geological past and say, okay, we know that we're burning fossil fuels today and that we're increasing the amount of carbon dioxide in the atmosphere. Are there past events where that's happened? And if so, can they tell us about how long it takes for climate to go back to pre-disturbance values? And so for the climate example, there's an event at the end of the Paleocene about 55 million years ago, where the climate warmed fairly severely and fairly rapidly. And we can see in the recovery of that event that it takes about 100 to 200,000 years for geological processes to completely remove all of that excess carbon dioxide.
Payne tells me that there's still a lot of questions left to answer to really understand previous mass extinctions and what they can teach us about today's mass extinction. But he and his students are working hard to fill in some of those gaps.
You often think that because of the way science progresses, that all these kinds of basic questions must be answered and that we're going after these nitty-gritty details right now. And that turns out not to be the case in paleontology, that the basic biological history of the planet, lots of it is still completely unknown or largely unknown, to the extent that you can come up with very basic questions we don't know the answers to.
Today's extinction can only be understood by looking to the past. From seemingly simple observations, we've been able to extract this rich history of evolution of life on Earth. And it's the work of scientists like Jon Payne that allow us to better understand what animals go extinct, what animals survive, and why. Thanks for watching. We'll see you next time.